Okay, so now I'm bringing you in our mechatronics and robotics lab. Here to talk to you today is our faculty member for Mechatronics and Robotics, Mr. Mark Hyam. Hi, Mark.
Hi, Jess. How are you today?
I'm great. How are you?
I'm doing well. The number one question we get when people walk in is they stumble over that big word mechatronics. I've been called Megatronics. I'm not Megatron. I would love to be, but we're not. But it's mechatronics, and that's one of the reasons we put the poster up. Basically, a mechatronic system is any of the following or any combination of the following. So it's a mechanical system with electronic controls, computer controls, control systems in general, or a robot. A robot is a very good example of a mechatronic system. So then the question is, well, why call it mechatronics? Well, when I was a technician in the Navy, you were an electrician, an electronic technician, or a machinist mate, and you never worked on anybody else's equipment. Nowadays, if you're a mechanic, you have to understand how the electrical controls work. If you're an electronics technician, you need to know how the electrical and mechanical parts work. The common term in some shops is called multi-skilled technician. That doesn't have a lot of class to it. Mechatronics has become a very popular term in the engineering field as a blend of all the different fields of engineering. So why use mechatronics if you can't find a job in mechatronics? Well, because every company that has one of these maintenance technicians or control technicians or instrumentation technician calls it something different in their company anyway. So we went with the term that the universities and Skills USA's contest has been using for almost 20 years now. We've been involved in the mechatronics contest for the Skills USA since 1999. And we see this as a growing field. Michigan Tech has recently opened a master's degree in mechatronics as well.
Very nice. Thank you. Can you show me what you're standing next to here?
Well, these are my robots. What we're standing in front of is one of our FANUC LR mates. We have 6 of these robots in the case. We can wheel them in and out of a classroom if we need to. We usually leave them set up here in the lab. They are available for teaching basics of programming and also for vision system where we can use the camera to identify different pieces and parts. So what this one's going to do is this robot is programmed to dump out all the pills onto the work area. It'll start with the bottle full of white pills. And then it will go for the bottle full of red pills. You can hear, if you listen quietly, you can hear the air blowing. This is using pneumatics, which causes that louder noise as the compressor tries to refill the air tank. Now that air tank compressor running causes some vibrations, so what we've done is we've built a time delay into the program. So hopefully before this light comes on and it takes the picture with the camera, we have waited enough time that the compressor stops running. So we are just waiting for the time delay. The compressor started late, so I'm not certain that it's actually going to stop. So the light comes on and we take the picture. And what it should do now is that first thing it does is identify all the white pills, and it goes and finds them. The interesting thing is we taught it what one white pill looks like, and it sees them, identifies them, and recalculates the position so it can grab the ones that are there. Notice the compressor was still running, so we had a little bit of a flub there. We'll see if it catches it when it looks for its pickups. And we have a red pill near the corner which didn't get picked up. One of the things in the class is they would often have to work on adjustments to the program and adjustments to the placement to minimize these little errors. Now again, we left 3 whites and 1 red. Let's see which ones they can pick up. Now that the compressor had stopped, we're a little out of sequence on our compressor running. And it's going to try this red one again, and it did pick him up. So even though it missed it the first time, it has that second one built in, and then it's just going to repeat itself. This robot doesn't mind. It'll run this as long as we want it to run. We have a lot of good trainers in the lab. One of the things I'm really proud of is this is our series, what we call Learnline. It's from a company called Festo. With it, we can do pneumatic training, we can do hydraulic training, and we can do electrical controls of both of those. So what we have here is this was actually designed by the students, and I tell them what it needs to do, tell them the specs. They have to design the circuit and then build the circuit to their design. If they build to their design and it doesn't work, they have to go back to the drawing board. I won't let them just fix it on the fly. And what this one is going to do is when I hit the start button, this cylinder is going to extend slowly, retract very quickly, and it's going to repeat that. I believe it's set for 5 times. So when we hit the start button, it extends, retracts slowly, and I was already at the max. So I'll have to hit the reset. Now that I've reset my counter, now it should go out multiple times. And again, 5 times. When I hit my reset, it will start again. So again, that's built in, but there's no computer brain giving this a program right now. This is all done by the electrical controls. Now, one of the other things we do talk about is process control. This trainer is what they call a compact process control system. And with the touch panel or running from a computer, we have our option. But we can run this for either level control, pressure control, flow control, or temperature control. We actually have a heater and a temperature detector in this lower tank. What it's doing right now is I've set the set point for 4 liters, and it is pumping things from the bottom tank into the upper tank, and then it should be able to maintain a level of approximately 4 liters based on the markings. So what the students will need to do, one of the things with this one, it's out of calibration right now. They need to calibrate so that when this detector tells it, actually this detector, tells it it's at 4 liters, that it lines up with our liter marks on the side. By the way, one of the other things we've had them do is verify that those marks on the side are accurate. So if I actually say 4 liters, I really have 4 liters. One of the fun things my students deal with is what is a liter, but we do deal with the metric system as well. So this will do things in either PID control, which is some fancy terms for proportional, integral, and differential control, or in an on-off control like a heater or for a furnace system does. So we use this to teach the basics of process control and what the different modes of control are. And we use this both for Mechatronics Robotics students as well as the water technology students as well, because they'll be working on systems obviously in a much larger scale. All right, again, one of the items that we do work with is something called a programmable logic control. I'm holding a small one in my hand, and these are basically the computer brains that run a lot of things we see around us in the world, including things like traffic lights. So this was actually a trainer built by my students. It uses one of these little, we call them a brick. This is a Micrologics 1000 by Alan Bradley. And then it uses relays on the bottom. And this is programmed to run a basic stoplight sequence. All right, these are our industrial motor control trainers. Now, we do a lot of things with simulations and as much as we can, but we also like to do a lot of hands-on. So these are designed to work just like a real motor control system in the real world. And one of the things our students need to learn to do is they need to learn to run wire, cut the wire off to the right length, install it onto the terminal boards, and run it in a safe manner through the control panel. What we have here is this has, we have about 4 different types of motors. We have AC and DC motors. We also have single-phase AC and 3-phase AC motors that the students have to mechanically set them up. They have to build the linkage to the drive system, and then they have to build it to print so that it functions the way it's designed to. So again, this is a case of we've done the theory, we've talked about how this is supposed to work, and then the students have to actually come and do the tasks like they will when they're on the workforce.